The largest warship ever proposed was going to be made of frozen water, 2,000 feet long, twice the size of the biggest aircraft carrier that existed in 1942. It would carry 200 bombers on a deck made of ice. Torpedoes could not sink it because the ice would freeze back within hours. Churchill approved it personally with a handwritten note. A prototype was built in secret on a lake in Alberta. Then the atomic bomb ended the war before it could sail. Almost built. Case number 059. The ship that could not be sunk. Geoffrey Pyke was 49 years old in the winter of 1942. He was a British inventor. He had no engineering degree. He had dropped out of Cambridge without finishing his first year. He was a journalist, a spy, an amateur educator, and a semi-professional annoyance to the British establishment. He was also brilliant. Pyke had escaped from a German prisoner of war camp in 1915 by hiding in a laundry basket. He had founded a progressive experimental school in Cambridge that let children lead their own lessons. He had proposed sending British motorcycle troops to fight in Norway in early 1940, dressed in white so they could disappear against the snow. Some of his ideas worked, most did not. All of them were unusual. In the winter of 1942, he was living in a small, unheated flat in London. He had tuberculosis. He wore 3 sweaters indoors because he could not afford coal. He read technical journals borrowed from the Royal Institute. He wrote long letters to strangers about ideas nobody had asked him for. A colleague who worked with him during the war described Pyke as the strangest genius he had ever met. He said Pyke thought about problems from angles nobody else would consider, because Pyke did not know what a normal angle was. In September 1942, Pyke sent a 232-page memorandum to Winston Churchill's chief military advisor, Lord Mountbatten. The memorandum proposed building the largest warships in human history from frozen water reinforced with wood pulp. Mountbatten read it that same night. He carried it to Churchill the next morning. Churchill wrote a note on the cover. The note is preserved in the British National Archives today. The Battle of the Atlantic was killing Britain. By the end of 1942, German U-boats had sunk more than 700 Allied merchant ships. Britain imported 2/3 of its food from overseas. Fuel, ammunition, medicine, aircraft parts, all of it had to cross an ocean where the Germans were sinking 1 ship every 20 minutes at the peak. The math was clear. If the sinking rate did not fall by early 1943, Britain would run out of food and industrial supply within 18 months. The war would be lost not on any battlefield but on the North Atlantic seabed. Allied aircraft carriers could close the gap. Bombers launched from carriers could patrol the middle of the ocean where U-boats hid. But conventional aircraft carriers were made of steel. Steel needed to build tanks, aircraft, and artillery. Britain could not spare enough steel to build the fleet of carriers the Atlantic needed. Something else was needed. Something that did not require steel. Something that could be built quickly, cheaply, and unsinkably. Water was free. Ice formed itself. In this atmosphere, a 232-page memo about warships made of frozen water arrived on Churchill's desk. And Churchill did not laugh. He wrote in his own hand, in the top margin of Pyke's memorandum, the following instruction: cautiously examine. The advantages of a floating island are so dazzling that they do not at the moment need to be discussed. There are no doubt some technical objections which will need to be met. That single note was enough. Within 72 hours, Mountbatten had convened a secret committee of British engineers and physicists. They were told the project name. It came from the Old Testament book of Habakkuk, chapter 1, verse 5. I will work a work in your days which ye will not believe, though it be told you. Project Habakkuk was born. Here's what almost was. The first problem was that ice was fragile. Ordinary lake ice under pressure cracks along its crystal boundaries. A ship made of pure ice would break apart the moment a submarine detonated a torpedo against it. Pyke had proposed something more interesting than lake ice, but he had not yet built any of it. The committee assigned 2 scientists to test his idea: Hermann Mark, an Austrian polymer chemist who had fled the Nazis, and Max Perutz, a young biochemist working on protein structure at Cambridge. Neither of them had ever built a ship. They spent the winter of 1942 in a refrigerated meat locker underneath Smithfield Market in central London. They mixed lake water with sawdust in different proportions. They froze the mixtures into small blocks. They tested them against rifle fire, against hydraulic presses, and against slow melting under lamp heat. The material that emerged was called Pykrete. named after its inventor. It was 14% wood pulp and 86% frozen water. It was harder than concrete. By August 1943, Mountbatten had a small block of Pykrete and a service revolver. The Quebec Conference brought Churchill, Roosevelt, and the combined chiefs of staff together for 11 days of strategic planning. Mountbatten was scheduled to present the habakkuk concept to the assembled leaders. He decided to demonstrate the material personally. He entered the conference room carrying 2 blocks. One block was ordinary ice. The other was Pykrete. He placed them on the floor at the far end of the room. He drew his sidearm. He fired at the ice block. It shattered into fragments as expected. He fired at the Pykrete block from the same distance. The bullet ricocheted off the Pykrete, crossed the conference room, and passed within 6 inches of Admiral Ernest King, commander of the entire United States Navy. King did not move. He looked at Mountbatten. He looked at the intact Pykrete block. He said one sentence to Roosevelt in a private conversation that afternoon. The Americans committed $20 million to Project Habakkuk before the conference ended. Construction began in Patricia Lake, Alberta in the winter of 1943. The site was chosen for cold temperatures, remote isolation, and freshwater ice supply. A team of Canadian conscientious objectors, men who had refused military service, were assigned as the labor force. They were told they were building an insulated barge for cold weather freight experiments. They were not told they were building the prototype for the largest ship in human history. The prototype was 60 feet long, 20% scale of one section of the planned full ship. Built from steel framework filled with layered Pykrete, insulated with tar paper, and cooled by a network of internal refrigeration pipes carrying cold brine. It weighed 1,000 tons. It floated. It held its shape. Cameras filmed its construction from December 1942 through February 1943. Sound was recorded. Detailed notes were kept. All of it was classified as top secret and shipped to London in sealed diplomatic pouches. An engineer who worked on the Alberta prototype later described the moment they turned off the refrigeration for 1 hour as a test. Nothing happened. The ice held. The full ship on paper terrified everyone who looked at the numbers. 2,000 feet long, 300 feet wide, 40 feet thick hull walls of solid Pykrete, total mass 2 million tons. That was 26 times the weight of the largest existing aircraft carrier. The refrigeration alone required a dedicated power plant generating 350 megawatts, enough electricity to power a small city. All of it running around the clock forever to keep the ship's own hull from melting into the ocean beneath it. The propulsion required 26 separate electric motors mounted in external pods because internal engine heat would melt the hull from inside. Each motor produced 1 megawatt. Combined, they would push the ship through the North Atlantic at a maximum of 7 knots. 7 knots was slower than a U-boat. Hermann Mark calculated the ship's minimum turning radius at 4 nautical miles. It could not maneuver in the open ocean. It could barely maneuver in the North Atlantic itself, but it could not be sunk. Every engineer approved the design and quietly noted it was insane. By October 1943, the first realistic cost estimate arrived. Building one full-scale habakkuk carrier would cost £70 million. In the money of the time, this was roughly equal to building 10 conventional Illustrious-class aircraft carriers, or 18 Colossus-class light carriers. Britain was fighting a total war. Every pound spent on Habakkuk was a pound not spent on radar, Spitfires, or Bomber Command. The Royal Navy could get 10 times more useful aircraft coverage of the Atlantic by building conventional carriers with the same money. The mathematics were undeniable. But Churchill had already committed. Mountbatten had already promised Roosevelt. Canceling required a face-saving reason. The reason arrived on its own. But between Mountbatten's revolver demonstration in Quebec and the quiet cancellation, there was a moment when Habakkuk almost stopped being a paper project. September 1943, Patricia Lake, Alberta. The prototype had held its shape through spring melting. Instrumented sensors buried inside the Pykrete showed the refrigeration system was working. Structural stress tests conducted by Royal Canadian Navy engineers confirmed the material would survive North Atlantic wave conditions. Mountbatten wrote to Churchill on September 17, 1943. He requested authorization to begin ordering the industrial refrigeration plants and steel framework for the first full-scale ship. Delivery of Habakkuk 1 was projected for late 1945. 2 additional ships would follow in 1946. Churchill signed the authorization on September 19th. Herman Mark and Max Perutz began drafting production specifications the following week. Canadian and American shipyards were quietly notified they would receive priority steel allocations for a new construction program. A site was selected for the first full-scale build. Prince Rupert, British Columbia. Cold water, year-round. Deep harbor. Existing rail links for materials. Isolated enough for secrecy. The first steel arrived at Prince Rupert on October 1st, 1943. Foundations for the construction dock were surveyed. Preliminary excavation began the same week. Local newspapers reported a large classified naval project without knowing what it was. Rumors in Prince Rupert suggested a new kind of submarine base. By late October, 300 workers had been transferred to the site. Barracks were being built. A perimeter fence was being erected. The largest construction project ever attempted by a wooden shipbuilding industry was 2 months from breaking ground on the impossible. An engineer who visited the Prince Rupert site in November 1943 later described walking through the empty ceremonial gates that had been prepared for the eventual launch of the first ice carrier. He said, standing at the water's edge, you could see exactly where the ship was going to sit. The horizon was not big enough for the ship. One committee killed it. The Habakkuk Review Board convened at the Admiralty on December 8, 1943, with instructions to decide whether the project should continue at full pace or be reduced. Present were Admiral Sir Andrew Cunningham, First Sea Lord, Sir Charles Goodeve, Assistant Controller of the Royal Navy, Herman Mark and Max Perutz representing the science team, Mountbatten representing combined operations. Pyke was not invited. Cunningham presented the cost analysis, £70 million per ship, equivalent to 10 conventional carriers. Timeline 18 months minimum. Refrigeration requirement 350 megawatts continuous per hull. Then Cunningham presented the current state of the Battle of the Atlantic. B-24 liberators from Iceland and Newfoundland had finally closed the air gap. U-boat losses had climbed from 3 per month to 11 per month. Convoy losses had dropped by 70%. Submarine warfare no longer existentially threatened British supply. Nobody said the word cancel. The formal recommendation was suspension pending further testing. By January 1944, the industrial refrigeration orders were quietly rescinded. By March, the Prince Rupert construction site was closed. By June, the 300 workers had been reassigned to conventional shipyard projects across the Pacific Northwest. The Patricia Lake prototype was left in place. Its refrigeration was switched off in the summer of 1944. It began melting immediately. It did not finish melting until 1946. 2 years to sink 1/20th of one ship. Full-scale Habakkuk would have taken 20 years to melt if abandoned. The math Pyke had promised was proven correct by the melting rate of his own canceled prototype. Nobody noticed. Geoffrey Pyke died on February 21, 1948. He was 54 years old. He was found in his unheated London flat by his housekeeper. He had swallowed a lethal dose of barbiturates the previous evening. Beside his bed were the manuscript pages of his last unpublished invention proposal, involving the use of human pedal power to generate hospital electricity in developing countries. A note pinned to the manuscript read only, "Sorry. I have been unable to secure a hearing." The coroner recorded suicide by overdose. The verdict added that the deceased had been in a state of severe professional discouragement for several years. News of his death appeared as a single paragraph in the Times of London 2 days later. The paragraph did not mention Habakkuk. The project was still classified. Habakkuk remained classified until 1974, when the wartime papers of the combined chiefs of staff were released to the National Archives. Journalists who read the papers assumed the ice carrier project had been a joke, a wartime hallucination, or a piece of British propaganda that had been quietly forgotten. Then someone visited Patricia Lake. The prototype was still there, or rather, the remains of it. 60 feet of steel framework rusting on the lake bottom in 15 meters of water. The Pykrete had melted decades earlier. The refrigeration pipes, the sensor housings, and the outer steel skeleton had sunk in a coherent geometric arrangement that matched exactly the design specifications preserved in Mountbatten's papers. Canadian divers photographed the wreckage in 1975. It was declared a historical site. Local dive operators began running amateur expeditions to see it. The full-scale ship was never built, but Pyke was proven right about Pykrete itself. In 2009, a research team at MIT reproduced the Pykrete and Mark experiments using modern equipment. They confirmed that Pykrete, at optimum wood pulp density, is stronger by weight than concrete, resists shattering by rifle fire, and melts approximately 100 times more slowly than pure ice. They also confirmed that a 2 million-ton Pykrete ship, properly refrigerated, could remain structurally sound in ocean conditions indefinitely. The engineering was correct. Only the economics were impossible. 3 years later, the BBC funded a documentary team to construct a small Pykrete boat on a lake in Switzerland, 20 feet long, 2-people crew, refrigerated by external ice packs. It sailed successfully across the lake and back. It survived collision with a wooden pier that would have destroyed a fiberglass boat. Pyke was correct. The engineers who dismissed him in December 1943 were also correct. Habakkuk would have worked. It would also have cost more than any nation could afford, propelled itself slower than any submarine, and been operationally useless the moment the atomic bomb ended the war it was designed for. He was right about the material. He was wrong about the world. His original 232-page memorandum sits today in the British National Archives at Kew. It has been requested by researchers 11 times since 1990. All 11 requests were made by graduate students in mechanical engineering. The blueprints still exist. The largest warship ever proposed was going to be made of frozen water, 2,000 feet long, twice the size of the biggest aircraft carrier that existed. It could not be sunk by torpedoes. Churchill approved it personally. A prototype was built. It floated. It held its shape. Then the bomb ended the war before the ship could sail. The blueprints sit in the archives at Kew. The prototype rusts on a lake bottom in Alberta. The inventor is buried in London. The ship was never built.